All right, let's get into the criteria to test the difference between two population proportions for independent samples. These are going to be very similar to what you've seen before. So number one, they have to be independent and random. Two, this has to be greater than or equal to 10. So when you look at that, that is testing for normality. You need to do it for each of the proportions because there's two populations. And then you need to make sure that there's independence. So each sample is less than 5% of each of the populations. 5 steps. Determine the null and alternative hypotheses. Here are the 3 ways that they can be constructed. You're going to keep it just as P sub 1 and P sub 2. You're not going to actually put numbers in for here. Note that P sub 1 is the population proportion for population 1, and P sub 2 is the population proportion for population 2. Step 2 is select a level of confidence alpha, depending on the seriousness of making a type 1 error. Step 3 is use number 14 on your calculator sheet to obtain the p-value and the test statistic. If the p-value is less than alpha, reject the null hypothesis. If p-value is greater than alpha, do not reject the null hypothesis. And step 5, state the conclusion. Let's look at an example. In clinical trials of Nasonex, 3,774 adult and adolescent allergy patients 12 years and older were randomly divided into 2 groups. The patients in group 1, the experimental group, received 200 micrograms of Nasonex, while the patients in control 2, in group 2, control group, received a placebo. Of the 2,103 patients in the experimental group, 547 reported headaches as a side effect. Of the 1,671 patients in the control group, 368 reported headaches as a side effect. It is known that over 10 million Americans who are 12 years and older are allergy sufferers. Is there significant evidence to conclude that the proportion of Nasonex users who experience headaches as a side effect is greater than the proportion in the control group at the alpha equaling 0.05 level of significance? Okay, so what I would do for all of these, now that we're getting into quantitative, qualitative, we have a whole bunch to choose from for 2 populations. We will. It's a good practice to first determine, is this qualitative or quantitative? We're looking for proportion, so that's going to indicate qualitative. Okay, and then is this independent or dependent? Right, it's going to be independent because your allergy isn't going to depend on anybody else's allergies. And no, there's 2 populations. So once you know that information, you go to your overview sheet, go to qualitative, 2 population proportions are independent. So once you have this filled in, you'd be using this information right here. So let's first verify the conditions. They were random, and we verified that they were independent. Okay, are they normally distributed? So we need to verify these formulas. So let's pick the first group. We had 2,103 patients in the first group. That's our N. And then our proportion is going to be those who reported a headache out of the total. So 547 over the 2103. When you do this on your calculator, you should get about 405. that's greater than or equal to 10. So that is normally distributed. And then do that again for the second group. We have 1,671 and 368 of them have a headache. So you can take that divided by total to get your proportion. When you do that, you should get about 287. That's greater than or equal to 10. So these are normally distributed. And then we need to figure out if they're less than 5%, the sample size, and they are. Sample sizes are each no more than 5% of the population sizes. All right. There's 2,100 is definitely less than 5% of patients 12 years and older, and 1,671 is less than 5% of the population as well. Okay, now we get into step 1, determine the null and alternative hypotheses. So we know we're doing proportions, so we can write all of this down. Now all we really need to do is figure out this symbol, this inequality. So let's go back up. Let's look at the question. The proportion of Nasonex users who experience headache is greater than the control group. So this is going to be greater than, so P1 is Nasonex. P2 is your control. Okay, just so you can see this visually, there's another way to write these. Say you subtracted P sub 2 on over to the left-hand side, you'd get P sub 1 minus P sub 2 equaling 0. Right? These would cancel. That would be your null, and your alternative would be P sub 1 minus P sub 2 greater than or equal to 0. So this is another way to write it. Again, P sub 1 is Nasonex. P sub 2 is your control. Step 2 is determining your alpha. They give us 0.05 as our alpha. And then we need to use number 14 on our calculator sheet to figure out our p-value. So stats, test number 6. So x sub 1 is going to match up with P sub 1. So you want the Nasonex information for your x sub 1 and n sub 1. So Nasonex, there's 547 that had headache out of the 2103. And then P sub 2 corresponds with x sub 2 and n sub 2, and that's your control. We had 368 out of the 1671. And we're looking for greater than. Our z-score is, our z-test statistic is 2.84, and our p-value is 0.0022. Here's the proportion for population 1 and proportion for population 2. All right, so let's go back. Step 3, our test statistic is 2.84, and our p-value is 0.0022. Step 4 is to compare your p to your alpha. That is less than your alpha, and when it's less, we reject the null hypothesis. And step 5 is to write your conclusion. So we can say there is sufficient evidence at the alpha equaling 0.05 level of significance to conclude the proportion of individuals 12 years and older taking 200 micrograms of Nasonex who experience headaches is greater than the proportion of individuals 12 years and older taking a placebo who experience headaches. The p-value of 0.002 means that if the null hypothesis that p sub 1 minus p sub 2 is equal to 0, or p sub 1 equals p sub 2 is true, we expect 2 samples in 1,000 to yield the results we obtain. The observed results are unusual because the p-value is less than the level of significance, alpha equaling 0.05. We reject the null hypothesis. Practical significance revisited. Looking back at the results of the last example, we noticed that the proportion of individuals taking 200 micrograms of Nasonex who experience headaches is statistically significant greater than the proportion of individuals 12 years and older taking a placebo who experience headaches. Again, statistically significant means that we reject the null hypothesis. However, we need to ask ourselves a pressing question. Would you not take an allergy medication because 26% of patients who experienced a headache taking the medication versus 22% who experienced a headache taking a placebo? Most people would be willing to accept the additional risk of a headache to relieve their allergy symptoms. While the difference of 4% is statistically significant, it does not have any practical significance.